Good afternoon, dear participants. So I have just shared a GitHub URL in the chat. Are you able to open that? Dear participants, can you hear me? Okay, so please check the GitHub URL and see if you can download those datasets. So we'll start at 2:30. So please check if you can open the GitHub and download those datasets. Can someone confirm if you can download? Yeah, at this point, there are 3 files, and these 3 files are datasets. So I think some of you have confirmed. So that means this URL is working fine. So I should have another person assisting me, Mr. Gyanendra, but because of some technical problem, he is not able to join. So I will, after some time, I will start the tutorial, so lab sessions, and in between he might be joining and helping us also.
Sir, actually, WebEx can access it through only Windows machine. So that is a problem. He's accessing through Ubuntu. That's why the problem arises. I requested him. And,
I think, yeah, probably he probably not aware of that. So maybe yesterday he joined through mobile. So maybe, yeah. So I think for tomorrow session, probably he will fix that. So maybe in between, let him join. Yeah, so I will probably start. So one question is, sir, can please send what to download? Okay, so at present, so you will have only data sets in the GitHub. I'm sending the GitHub link again. I think some of you have missed it. I'm sending the GitHub link again. Here, you will be having only the data sets. So I am not uploading the program now. The idea is that maybe we'll try to build the program together. Okay, and once you are able to build one model, remaining program will upload. Then you can download and run the other models also. Just to give a feel of some interactive doing together. I'm thinking that some basic steps we will be building together. Okay, so Shall we start now? So I think some more participants are joining, and once if we start, maybe they may be missing this URL. Maybe we'll just wait for a few more minutes. So if you have any query, please communicate to me through the chat, not the question answer, because I have not opened the question answer. Only the chat window I'm opening. Uh, the reason is if I open the question answer again, this chat window is getting minimized. So I'm opening only the chat windows. So if you have some query, please communicate to me through chat window. And this is a kind, I'm trying to make it like an interactive say, mode. So maybe, yeah, communicating through chat, yeah, that may be more convenient. Please communicate to me through chats. Okay, so we have 2 hour session, and we are going to discuss some of the basic machine learning models. And gradually we'll try to move to the advanced model. But today we'll start with the very basic traditional classic machine learning models. So many of you might have already used these models. So, but keeping the diverse background of the participants, so we have decided to start with the basic. So those who are kind of already aware of it, uh, please you can also help us to probably take it in the more better way. Otherwise, also please bear with us. So the first 30 to 45 minutes, I'm thinking of briefly explaining the different classification models without much technical details. Because the moment we go to the technical details, then then so some of the participant may have issues. So let me try to make it as non-technical as possible. And the idea is when you try to run this classification model, you should have at least some high level understanding of what is going on inside. That is the idea. But for the say mathematical formulation of these models, you have to refer standard resources and so on. So if you look back about 10 years back, right, building some machine learning model is a very challenging task. But today, because of various tools that are freely available, it has become very easy job. So that's why everyone is doing machine learning. Okay, that is what now everybody is working is machine learning because these tools can be easily used and if you just know what to be done and what are you expecting by using these tools directly, you can do the task. But earlier, this kind of tool you have to build yourself. So that time it was a big, say, kind of very challenging area. Now I think because of the availability of various tools, say nobody writes their own codes now. So people try to reuse the available codes. So we are so in a similar line. So there is no point in say writing these programs again. So we are just trying to use some standard tools and how to use that tools for building different classification models, clustering models, and then how do you actually evaluate and what do you mean by say training and testing that you have to see. Okay, when you write a paper or something, you have to evaluate different models with different data sets and compare those results. Okay, so that is the main idea of these sessions. So overall, say after the session, you should be able to understand, like say given a data set, how do you build different classification models and how do you compare them. That is the whole idea. So with this brief background, let us start with say basic classification model. Okay. One question is, can a person with a little knowledge of programming start ML? Yes, yes, yes. That is the whole idea. Now you hardly you need to write few lines of codes, okay, for doing any ML program. That is the kind of beauty of say ML today. Okay, so that is the idea. Okay. Not able to see the link. I think you have to. Okay, I think for the late joiners, some participants are joining late. So please ping me because you may not be getting this message if you're joining late. Okay, I have just fired the link again. Okay. Post it in Telegram group. What is this? So let me share my screen now, and I'm going to start with very basic understanding of say different classifiers. Okay. So the example that I'm going to use in this discussion is similar to the example that I have taken in my yesterday session. Okay, so let me quickly recap what is this data sets. The same vehicle example I'm taking, and the first column is like a vehicle ID. Okay, the next three columns, wheels, height, weights, are the three features that I have used for defining my vehicle. And the last column is the class. Say last column is the class. So there are two classes. One is the car and another is a bike. Okay. So these are some arbitrary samples that I have created for using in this discussion. Uh, can you see my screen and can clearly? Do I need to increase the size of this document? Telegram group, I'm not able to. Okay, let me just check. Yeah, in the list of attendees, I'm not able to see the Telegram group. Uh, the participant is telling I'm not audible. Okay. So this is this same example I'm going to take, and for the I have already defined what we mean by classifier, and these are the five different classifier I have chosen to say discuss in this session. But you in the tool that we are going to use, there are classifier already built, so you can also directly explore them. But the reason why I have selected this five classification frameworks is that they work in different ideas. the idea of these different 5 classifiers are different, and they are kind of most fundamental classifiers. Okay. So first, and for any understanding any classification framework, I think one need to know something called Bayesian classifier. This is the most classical classification methods, and many other classification methods are based on this Bayesian classification. Okay, so let us briefly start with what is Bayesian classifications. So I'm going to quickly touch upon these methods because maybe so that I can cover all these classification in next 30 to 40 minutes. Okay. So let us see what is Bayesian classifier. So Bayesian classifier, sometimes it is also known as the say discriminant-based classifier. So it works in a very simple idea. Okay, so we have to. The whole idea is given a vehicle, taking the vehicle example, given a vehicle, what is the class level? So I need to find probability of a class, say car, given a vehicle, say vehicle, first vehicle, vehicle number 1. This is what I need to estimate. Likewise, if I have yes, I have car and a bike, so I need to also estimate probability of bike given vehicle 1. If I have more than one vehicle, let's say more than two, like say bus also, I also need to calculate probability of given a bike, what is the probability of being bus, something like that. So if you have two classes for the given example sample, you have to calculate probability of getting those two classes. If you have three classes, you have to calculate for all the classes. Okay, so in this example I have only two classes, so I'm removing this bus. So our task in the most say core is you need to calculate, estimate the probability of these two classes given the vehicle, and which one is larger. If probability of getting car is larger, then vehicle V1 is car. If bike is larger, then probability of V1 is bike. This is what we are going to do. Okay, this is what the Bayesian classifier. So probability of car given is larger than probability of bike, then it is a car, otherwise it is a bike. So this is what the Bayesian-based classifier. Okay, so this is going to use. Okay, then how do you calculate probability of car given vehicle 1? That is the question. Okay, so for calculating of car given this vehicle, I am going to use something called Bayes rule, or say something like Bayes theorem. Okay, this to use. Okay, so I'm just marking it red. So at the core of the classifier, okay, you have to use something called Bayes rule. So what is this Bayes rule? Some of you might already be aware of. So if you see Bayes, your conditional probability. Okay, this is like probability of A given B. Right? This is conditional probability. Then if you expand this, conditional probability, you can easily see that it can be expanded as probability of B given A into probability of A divided by probability of B. Right? This is your conditional probability. Okay? So the moment, and let us see, so the moment you visualize this conditional probability as a Bayesian rule, okay, the way you are going to see is level, okay, and B is the sample that you are. This is like given the sample that is B, what is the probability of the class car? Okay, so A is the car and B is the sample. So this is called posterior probability. Okay, so whole task is to find given the indicator or say sample, what is the posterior probability of getting the class level. Okay, that is what the Bayes rule. So now in this, so when I see as the posterior probability, when I substitute this car and a vehicle into A and B, I get this. Can you please see that? So now probability of getting car given V1 can be defined as probability of getting the vehicle given a car. Okay, likewise, probability of the first part. So this part is called, this is the given the class called car of this car is satisfying this the sample that you have taken. Okay, so given the car, probability of getting the vehicle, that means if you just close your eyes and pick up a vehicle from the car domain, how likely you are going to pick up this vehicle, particular vehicle. Okay, so this is what first component, and this first component is known as the likelihood. Okay, then you have probability of car. This is probability of car is the prior. That means if you just randomly close your eyes and randomly pick up a vehicle, how likely that you're going to pick up a car? Okay, so that is the kind of prior probability. Okay. Then in the denominator you have P1 probability of getting vehicle. This is the evidence. So now define this Bayes rule in the form of prior probability is nothing multiplication of likelihood into prior probability divided by evidence. Okay, so this is the Bayes rule. So posterior probability, likelihood, prior, evidence, and so on. So in the same manner, you have to do this. You have to do this for bike as well, right? So when you bike, the same thing again. What is the probability of getting bike if you give the vehicle? So same likelihood prior than evidence. Then which one of these two probability is larger? If the probability with the car is larger than the bike, then V1 is car. Okay. So this is what we are going to do in the Bayesian classifier. Okay. Is again, how do you calculate the probability of getting a car given this V1? Okay, how do you calculate? So now, how do you calculate this probability? Are you following? Are you with me now? So, so now we need to calculate the probability of getting car, the vehicle V1. Okay. Then as we said that the vehicle should be represented in some form that is understood by my program, right? So Bayesian, my program understand something called vector space model, right? So what do you mean by vector space model? That we have, as we understood yesterday, every sample will be represented by a vector with the associated features. We have three features, and every is represented by this vector of dimension 3, wheels, height, weight, and so on, right? So now when I say I'm giving the vehicle 1, that is nothing but I'm giving the first row, the this vector associated with the first vehicle, 4, 7, and the 700. Okay, I think my examples are quite little different, so let me take a vehicle number 4, because 4, 5, 500, right? So I have 4, 5, 500. So this is vehicle 4. So when I say vehicle number 4, this is nothing but a vector 4, 5, and a 500. So now I need to calculate probability of this. This is nothing but, so if you apply the Bayes rule, I have the likelihood. I have the likelihood. Then I have the say uh, prior probability. I have the evidence. Okay. So before going further, I just wanted to here that this evidence, the denominator component, when you compare car and a bike, so when you compare between the car and the bike, you can see the denominator is same. This evidence part is same, right? If since denominator is same, whatever is larger in the numerator part, that will be the class level. And simply ignore the evidence part. Okay, so this component, this orange component, can be conveniently ignored because this is going to be same for both the car and the bike. So in the calculation, I'm ignoring this yellow component denominator. So I'm just using this numerator, that is the likelihood part and the prior probability. So now our whole task is to calculate this component. Okay. So how do you calculate? So if you see here, this is like so it's like, I think some of you might have already calculated probability of something like A, comma B, comma given C, right? If you want to expand this, how do you expand? If you want to expand this, you can expand this using chain rule. So in other words, this is like, so this particular part, if I have probability of C, this is equivalent to probability of A, comma B, comma C, right? In the conditional we have in here, this is when you have only two elements, right? You can also more than two elements. So when you have more than two elements, how do you decompose? You can decompose using the chain rule, right? So this is nothing but I can, I think you remember the chain rules. This can be further divided into something like probability of A given B comma C, probability of B given C, probability of, right? So this is what the chain rule. So I am just applying that here. So when I have three features here, given the class levels, so I'm just applied chain rule here. One after another, I have expanded. So when I expand, so I'm getting something like this. Okay. So this is exactly like, if I try to visualize in terms of features, this is exactly like given the, say, first features and the B, C, and the car. Okay, this is nothing but just the chain rule. Okay, probability of then B given C given car, probability of C given car, probability of car. This is what I'm getting, right? So this is what I need to estimate from my data sets. Given data set, I need to estimate this probability. Okay, this probability. Am I with you so far? Okay. So, but have done this operation earlier, you will easily realize if you have a lots of features and big data sets, this is a very operation, because for calculating this probability, what you need to do, you need to read every rows and check whether this second row is 5 or next row is 5,000, next row is car, and how many of them are. You have to do lots of counting. Okay, if you and this is going to be really expensive operation if you have lots of features. Means in the text mining you will see that number of features are in terms of thousands, millions, so on. Okay, so in such a scenario, calculating, estimating this probability is very expensive because you have to check every elements, compare all the elements in every rows multiple times. Okay, So this is going to be very expensive operation. So if you are using Bayesian classifier, you have to estimate this. Estimate this for car, you have to estimate this for bike, and which one is larger. Okay, but Bayesian classifier with more features is going to be expensive operations. So sometimes it is not practically feasible to apply in some real, say, real-time scenario. So instead of applying Bayesian classifier that we have started with, is approximated as something called naive-Bayes classifier. Okay, naive-Bayes classifier is a simplified or say variant of a special class of Bayesian classifier. Okay, Bayesian classifier as such is very expensive operations if you do apply on the data set with large features. So, but Bayesian classifier is going to be very fast classifier, and the people have seen that. Okay, in terms of performance, especially in the text domain, there is not much difference in the performance. Okay, so Bayesian classifier gives equal performance, almost comparable performance in many instances with that of the Bayesian classifier. Okay, so this is naive classifier. Naive classifier just try to handle issue of this computational cost because of this probability. Okay, so in the Bayesian classifier, they make some simplification. That class conditional independent. Class conditional independent means it says that features, occurrence of the features are independent to each other, conditional independent. Okay? Features are conditional independent. That means when I have, let me just rewrite again, probability of what I have was A, B, C, car. Okay. With class conditional independent, it basically means say features are conditionally. So that means A and the B are conditionally independent. So occurrence of A and is independent of occurrence of B. Okay, that means when you say, you know that in probability when A and the given B and A and the B are independent to each other, it is equivalent to probability of A, right? Okay, for the simplification. So this expression can be simplified now as probability of A given car. Okay. So now A is conditionally to B and C. So I can write this as the A given car. Okay. So that is what I'm simplifying here. So the moment I apply this simplification, it is called Bayesian classifier. Okay, so Bayesian classifier is nothing but, naive classifier. So naive classifier is nothing but Bayesian classifier with the class conditional independent assumptions, sometimes referred to as the Bayesian classification assumptions. Okay, so this is what the naive classifier. So this, we are applying the classification condition, which is class conditional independence. And then after this assumption, I can say that every feature is conditioned on the class. Previously in the Bayesian classifier, features are conditioned on the features as well as the class, right? Now I'm only on class levels, okay? So these are conditioned on the class levels. So this is the Bayesian, naive classifier. So that is what the simplifications, and with this simplification, the performance, the time taken for building this classifier will be much faster than the Bayesian classifier. Okay. Okay. So now, question is, now I need to estimate this features condition on the class, something like I need to calculate probability of 4 given car. Okay, so how do you calculate this? So you may calculate this in various forms. One of the simplest form might be just by counting. So a probability of 4 given car is nothing but in the data set among the car, how many cars having 4 wheels, right? So I just need to count how many cars are having 4, right? So likewise in the height 5 given car, how many cars are having height 5? This is what I need to count. So one way of doing is just by counting. I can simply count among the cars how many are having 4 wheels. That is nothing but probability of 4 given car. Then likewise, how among the car how many are having 5 feet. This is there are 2 cars with the 5 feet. Likewise, how many 500 kg of weights? There are 2 cars with the 500 kg of weights like this. So this is by simply I can count, and then I'm finding given these vehicles, probability of being car is this, and the probability of being bike is this. So this vehicle is a car. Okay. So this is the MeitY classifier. So in the MeitY classifier, when you use like scikit-learn or say some other tools, you may see that uh, sometimes like MeitY classifier with a multinomial kernel or say Gaussian kernel or something like that. So what is that? You should not be confused. That is all about how do you calculate this. Okay. So this way of counting is sometimes referred to as the maximum likelihood estimates. Otherwise, also, suppose when I say Gaussian, MeitY classifier, Gaussian kernel, that is what we are also going to see. That basically means it is assuming it means that the value, the distributions of in each features are following the Gaussian distribution. Okay, so likewise, okay, in some cases, when you have these discrete values, probability estimate might be easier. Have the continuous value. Let us say height instead of 7, I have something like 7.1. This may be something like 5.3. It may be something like 7.4. And this is something like, say, some real value. Okay. So when you have with a very close, okay, without quantization, some estimating this probability of, say, this height given car, okay, this might be, you may not have to calculate that probability. Okay. So instead of that, we can assume that each car classes, example, the values of the height in each of the class follow some probability distribution. Is it multinomial or Gaussian or Poisson distributions and so on? You can assume that it follows some probability distribution. Okay, so the moment suppose, so when you say MeitY classifier with Gaussian distribution, it basically means it follows a Gaussian distribution. These values follows a Gaussian distributions, and you can see that Gaussian distribution can be expressed something like this. And when here you have the mean and standard deviations. So given a class, if you find the mean and the standard deviation, I can find the probability of any values, any number, right? So using some probability distributions, you may be able to calculate. So you should not be confused when you have Gaussian say classification with multinomial or Gaussian classification with MeitY classification with Gaussian or MeitY classification with multinomial and so on. So multinomial or Gaussian or Poisson, these are the underlying assumptions. Okay, that you assume that these values so if I assume that it follows the Gaussian distributions, I'm using the say MeitY classifier with the Gaussians. Okay. So you not please confuse with that. Okay. So this is a brief discussion about uh, Bayesian classifier. Okay. So next is Centroid-based classifier. This is a simplest classifier. Okay, so what is centroid-based classifier? Centroid classifier is very simple classifier. What it does is, for every class, you try to find a centroid. That means, let us say, for the car, for all the car, you try to find some centroid. Centroid means of uh, car. You try to find the mean value. That means you try to find some representative point for each of the class, where mean value can be centroid, mean, medoid, and so on. Different, so depending on that. So in the centroid base, I'm assuming that central point is the representation point. So if I try to find centroid, let us say centroid of car, this is 4, and initially I was having 7, 5, just to make easier. Then centroid might be somewhere with 6 or something, right? It might be somewhere 600. So this is the centroid for car, 4, 6, and the 600. This is the central point for the car, right? Similarly, you find the central point for bike. Okay, you find the centroid point here. Okay, then what are the central points? This is 2, where 2.75 or something. 75. This may be, okay, sorry. This may be something like 1 or something like this. So this is for the central point for. Okay. So in the centroid-based classifier, you don't have to do anything. You just training the data set. You just find a central point of each of the classes. Okay. Now, when you get a new vehicle, okay, new vehicle. Say, let me say, new vehicle is having something like 2 wheels, something like 3 feet height, 200, 200 kilo of weight or something. Then what I am going to do is this vector, okay, between car central point and the point, which one is closer? So this is closer to bike, right? So this point is closer to the centroid of bike. So this is bike. Okay. So that's it. That is a centroid. How do you find the say distance between the centroid and the new vehicles? So because new vehicle is also a vector, centroid is also a vector. So what is the distance? So you can use any measure like say Euclidean distance, cosine similarity, where you can find the distance or similarity between the two vectors. Okay. So in some literature, you may find that people are using Euclidean distance. Some literature, you may find that it's cosine similarity. So using some uh, metrics or to measure the distance or similarity, you can see which one is closer. So you have to assign the class level of the closest centroid. Okay, that is the base classifier. So what is k nearest neighbors? Again, k nearest again very simple. Suppose in the k nearest neighbor, KNN, what I'm going to do is, so in the k nearest neighbor, there is no learning as such. Okay? It's also called as something sometimes lazy classifier or instance-based classifier. It has nothing like a learning, prior learning. So what it does is, you get the new examples, you compare your new examples that you want to classify with the existing set of samples and find which one is the closest. Okay. So this so if I say k nearest neighbors, what I will do is that given these new examples that I want to classify, find the k closest example from my training data sets. From my training data set, give me k closest example. So in this particular example, if I say something like 2KNN, means give me 2 closest examples from my training data, okay, closest to the examples, that the new vehicle that I want to classify. Okay, so this is like top K. So in this example, top 2 will be maybe among the bike. So among the top K, you check what is the dominant. If the dominant is bike, then it is a bike. If the dominant is car, okay, that is the K nearest neighbor. Okay. So now next I want to briefly explain, which is conceptually a little different from the previous classifier, and it yet one of the most studied classifier in the literature. So let me explain what is SBM. Okay. So for explaining this SBM is also called say discriminant-based classifier. Oh, sorry. Okay. Oh. Discriminant-based classifier, and the SBM is binary classifier. Okay, it can handle only two classes. You cannot have more than two classes by one SBM. But if you have multiple classes, you have to build multiple SBM and try to find which then other methods. We have to build multiple SBM classifiers and then see which one is dominant and so on. Okay. So by single unit of SBM, you can handle only binary classes. Okay. So the concept of SBM is like this. So let us visualize all the data points, some space. So let us say I have two-dimensional space. When I say two-dimensional space, I basically mean I'm using two features. Let us say I'm using wheels and height only, but I'm considering weights. If I consider three, say, features, then it's a three-dimensional space, right? Dimensional space. Just to understanding, let us say I'm using two-dimensional space, only two features, and all the samples are, say, plotted on this two-dimensional space. Let us say all the cars are the black dots, all the bikes are these white circles, for example. Okay. In SBM, what I'm trying to find is some kind of this hyperplane, this line that will separate these black dots from the white dots. This separating hyperplane. This is the target of. Okay. So the problem is between this, in this diagram, if you see between this black and the white, you may have able to draw several various like lots of hyperplanes that will separate from black to white. Okay. So you have infinite number of this hyperplane between black and. Okay. So you have, so which hyperplane is the best hyperplane separating this black and white? Okay, the best hyperplane. So this hyperplane is defined something called maximum margin. Maximum margin means what? So when I suppose say, if I say this central line, the middle line is the separating hyperplane that I have chosen, then I will draw another parallel hyperplane nearest black dots. Similarly, another hyperplane passing to the nearest white dots. So this H plus and H minus. The hyperplane passing through the nearest, say, samples, black and white samples, parallel to the separating hyperplane. So margin is something, the gap between this positive hyperplane and negative hyperplane. This is the margin. This between these two. Okay. So for different hyperplanes that you can put in between, this margin will be different. Okay. My target is to find hyperplane that gives you the maximum margin. Okay. So I am trying to hyperplane that gives me the maximum margin. That's it. So when I find the maximum hyperplane with the maximum margin, That is my objective. And once I found that, okay, these points, the samples, black samples and the white samples passing through this negative hyperplane and the positive hyperplane are called as the support vectors. So the support vector that we are taking, these are the vectors representing the sample passing through negative hyperplane and the positive hyperplane. So in these examples, I have three support vectors, one black and two whites. These are the support vectors. So advantage is vectors. I don't need to, I can simply ignore those remaining the black balls and white balls. And if I have only the support vector, I can reconstruct. So these are the advantages. So when you say about support vectors, okay, support vector machine, the target is to find this separating hyperplane passing through that separates the positive example, negative example with the maximum margin. Okay, this is the brief idea of support vector. In practice, what happened is this particular example that I have taken, they are well separated. Positive examples and negative examples are well separated. It may happen that there is no they are overlapping. Okay? So when you have the overlapping samples, that is what you are going to see in the practical scenario. Then there are solutions to handle that. One is called kernel. What we do in a kernel is that support vector machine with kernels. Kernel trick. What we do is that we project the sample in the higher dimension. In the dimension reduction that we discussed, high dimension is projected in the lower dimension. In the kernel, we project the lower dimension into the higher dimension. The idea is that the samples that are not linearly separable in the lower dimension may be separated in higher dimension. Okay. So if I am using such solution, that is called SBM with kernel trick. Okay. So another is instead of using kernel, another example I can do is if they are overlap, you just you just pull positive black dot in the other side and the white balls in the other side, and you pull and separate the amount of distance that you pull the examples, that is called slack. Okay, so likewise some kernel solution might be through slack and some other may what you call as the kernel trick. Okay, so that is the SBM, but high level just idea is you try to that gives the maximum margin. Okay, that is the SBM. So lastly, I will just briefly explain something called decision tree. Decision tree. So decision tree is again another form. So in all the previous classifier, find some rule, something like separating hyperplane and so on. So in the decision tree, we try to find some rules. Okay. So let us see what is decision tree. So let us say this table is the example that I want to build. Okay, first four columns are the features, and last column is the class level. You have something like idea is if you know the weather condition like outlook, sunny, temperature, humidity, windy, then I'm trying to predict whether there will be a cricket match or not. Okay, something like that. So if these are the play is the class levels and other fours are the features. So if I have this, my target is to come up with some rules. Say one example rule is so my target is to find to predict. So if I have a new weather condition, sunny, cool, high, then will there be a match or not? This is what my classification task is. Then for doing this, instead of using SBM and all, I let me try to come up with a rule. Rule is something like if outlook is sunny and humidity is high and windy is false, then yes, there will be a match, otherwise no. Something like we want to come up with some rules. Okay? So decision tree will allow you to create such a rules. Okay? So what is so we want to come up with such kind of tree structure. Okay, so where if you see here, all of these nodes, okay, these are the features: outlook, humidity, windy, and so on. These are the features, and the branch on the nodes are the value of the features. So outlook sunny, overcast, rainy, and so on. Humidity may be high, low, windy might be true, false, and so on. Okay. So I want to come up with such a rules given a data set, something like that. Okay. So that is what the decision tree. Okay. So given a data set, okay, you may have more than one possible trees. One is this examples. You may have another tree, something like this. This may be another tree. So in the first tree, you have outlook as a root. In the second tree, you have humidity as a root, and so on. You may have multiple possible such rules, and you have to find the best possible tree. Okay, among all these possible trees, what is the best possible tree? For finding the best possible tree, so the algorithm that I'm going to explain is something called ID tree, which is the most fundamental, say, decision tree algorithms. But I think I may not have time for explaining more details. So in the uh, tree, so what we think called information gain, and I'll just try to briefly see if I can explain this. What is how do we divide? So if you see here this figure, so the top level box is the entire data sets. Okay, so now I am trying to divide the entire data set by something called hair length. Based on the length of the hair, I am going to divide into the sub say sub data sets, left hand side and right hand side. That is the idea. So now, how do I divide? So I'm going to divide this using something called an entropy. Entropy of a data set is something like how much information it contains. Okay, then after dividing, how much change the informations. So amounts of uncertainty that is data set has, okay, after dividing. Okay, so the change in the uncertainty, that is what we call is the information gain. Okay, something called information gain. Then using information gain, we keep. I try to select the features that divide the data set into sub data set with the maximum information gain. Likewise, I will keep on dividing the data sets. At the end, I will come up with something. Okay. So once I get this tree, then I can form the rule something like if the weight of the person is less than 160, then here length is less than 2, he is a boy. Otherwise, he's a girl, and so on. Okay. So this is a to summarize, I'm sure that you still may be having lots of doubts here, but I think, but I'm just giving the notion of what is decision tree, but methodology, you please try to. So given the data sets, we plan to come up with such kind of tree, and coming up these trees like getting a rules. Okay? Then once I get the rules, we given a new examples, we parse through this tree and check what is the class level. So this is the brief idea of uh, decision tree. Okay. So with this, I have briefly covered 5 different classifiers, but there are various others classifiers. Okay. So examples, some questions are there, how to handle outlier in decision tree building. So I think let me explain this in between. Okay, just to because there are different ways of handling it, and it depends on what is the uh, say what kind of algorithm you are using. So if you talk about the ID3, then one way of identifying outlier, for example, let us say here in this example, the leaf node that you have in the leftmost is something like only one sample, one person you have. Okay, so when you have only one with these very complex rules, right? Then this might be a weak rule because you have this person. whereas other two rules are having say many persons, right? So instead of going up to this level, I can just stop in the second level with the small noise in the last in the say this lady's side. So if I do not proceed here, I have only one noise, and this noise might be due to some outlier. Okay. So this is also one way of handling outlier. Okay. So outlier may be handled by the amounts of uncertainty that you can incorporate, because when you try to get the perfect classifications, the supports that you get might be very small. Okay, so that might be outlier. So likewise, you can in different ways you can just one example. So I just completed uh, outliers, these 5 classifiers, and I think it is almost 55 minutes. So let me go to the next steps. So now we have built the classifier, okay? Then how to evaluate classifier? So after building the classifier, you have to evaluate, right? So for evaluation, there are several matrices, evaluation parameters. So some of the evaluation method people use is something called precision, recall, F1 measured or F measured, accuracy. Then we also call something like AUC score and so on. Okay. So let me try to briefly explain these 4 or 5 evaluation matrices. Then we'll start our lab session. So what is precision? And so for defining this evaluation, you need to understand this confusion matrix that I have just given here, this table. Okay, this confusion matrix. Confusion matrix, I have two things. One is called actual, and another is called observe. Okay, and what are these yes and no? These are the class level. This is yes. This is a car. Car is the yes, and no is the bike. Okay. Likewise, yes is the car, and no is the car. And yes is the car, then no is the bike, something like that. So if I'm assuming that yes or no in the binary cases. So one of the class level is yes, another is a no. Okay. So how do you visualize yes or no? Okay. So it's like if I want to classify, if I'm targeting car, okay, car is the yes. If I'm targeting bike, bike is the yes. Like you may have more than one class levels. Okay, so the thing that you are targeting is the yes, others are the no. Okay, so if I, in my case, let us say I'm targeting car is yes, bike is no. Okay, so what I have something like observe here. This is like now you have the classifier. In this classifier, you have given some examples. Okay, and this classifier will classify this input. Okay, then the output of this classifier, they are the observed. This is the output of the classifier. So output from your classifier are the observed. Okay, but your classifier may perform wrongly, right? It may misclassify. You are giving a bike, and your classifier may classify as a car. So car is observed, but actually you are giving a bike. Okay, so that is the actual. So actually you are giving these are the actual, and when you class levels, say actual, and what are you getting from the classifier is the observed or output. Okay, so this is what the actual and the observe. So before going to this, I just missed one point. So in any classification framework, there will be 2 types of data sets minimum. This is one thing is called training, and another is the testing. Can you see what I'm typing? So there will be 2 data sets. One is called training and another is called test or testing. So what is the training? training is the data set that I have considered for building my classifier. Okay, and once you build your classifier using the training data sets, you are all going to test your classifier. So testing are the testing data set are the data set that are used for evaluating your classifier. How good is your classifier? Okay, so in other words, also data. Let us say, if I say in this example, if I say out of this car, let us say I'm using 3 car for testing, training, and the first 3 bikes for training. So like say this, the yellow colors are the, let me say these yellow colors are the training. Okay, then I am going to build my classifier using yellow level samples. Okay, then I also need some data set, level data set to for evaluating my system. Those are the tests. Let us say my red are the testing. So that I am going to give these examples to my classifier and check what is my class levels, predicted class levels. If predicted class level is car and your actual class level is car, then it is correctly classified, right? If predicted level is bike and actually is a car, then it's misclassified. So in order to check whether it has been misclassified, the test data set should also have the actual class levels. Okay, so examples are also level data. So in the classification framework, quite often you will find something like training data and testing data. That is what we are also going to see in the lab programming. So please do not confuse with this. So training data set will be used for building a classifier. Testing will be used for evaluating your classifier that you have just built. And the performance evaluation, I am giving my test examples. I am giving my test example, test data sets to my classifier, and this is what I am finding, and in this confusion matrix. So this confusion matrix I'm going to build from my test example. Given test examples, I will check what is the class level. If it is a car, and this is what the observe. So observe is car. Then I will check whether is it actually a car or not. Okay. Then if it is actually a car, then it is called true positive. Okay. So in this confusion matrix, you will have something like true positive, false positive, true negative, and so on. Okay. So you need to understand these 4 components in order to define these performance matrices. Okay, please be attentive here. So what is true positive? True positive is the number of those test examples that are classified as yes, that are classified as car, and those and they are actually car. That means they are predicted as positive, that means car, and it is actually true. Okay, so they are positive as they are predicted as yes, and it is already true. They are car. Can you follow this? True positive means the classifier is predicting the sample as positive, actually positive. That means classifier is predicting as a car, and they are actually car. The true positive. What is false negative? The classifier is predicting as a bike, but actually it is a car. So the prediction is it is predicted as no, right? And it is false. That is a false negative. Otherwise, what is false positive? Classifier has predicted as the car. Actually, it is a bike. So classifier has predicted as positive, and this is false. This is a false positive. Likewise, classifier has positive predicted as negative. Actually, it is negative. Like it is predicted as bike, and actually it is bike. That is the true negative. Okay. So once I have this true negative, you have precision recalls Precision is nothing but among the predicted car, how many. So if I say precision for car, that basically means among the samples that are predicted as car, how many are actually car? That is the precision. That means true positive divided by true positive and the false negative. Recall is like among the cars, these are actually, sorry, uh, I just, so precision is like among the samples car, how many are actually car. This is the precision. Recall is like among the car, how many are actually identified as car. So you have 100 cars, and among these 100 cars, how many cars has been identified correctly? Is nothing but true positive divided by true positive and a false negative. So this is the precision, and the average of precision and recall. Okay, harmonic mean between the precision and recall, F1 measure or F measures, which is defined by 2 into PR divided by P plus R. Okay, actually this is nothing but a harmonic mean between precision and recall with a factor 1. What is accuracy? Accuracy is like among all the predictions, how many are actually true. True means how many are actually predicted as the car correctly, how many are actually predicted as the bike correctly. Okay, how many are predicted as car, how many are predicted as bike correctly among all the predictions. The precision and recall, and in addition to this, we also have something called AUC score. I think I will skip that part. Yeah. Uh, Okay, just to quickly say that AUC score, in order to understand AUC score, area under our curve, we have to first draw something like ROC curve. Okay, this line is called ROC curve. So what is ROC curve? This is the curve between true positive rate and the false positive rate, where true positive rate is defined as the recall and the true positive rates are same, and false positive rates are nothing but negative, how many are actually predicted as negative. Okay, this is the false positive rate. And for different experimental setup, if you find true positive versus false positive, you can draw such kind of curve. Okay, under this curve is called AUC score. So this is a brief method for evaluations. With the, let us see how to build my classifier. Okay. Any question at this point before we start the lab session, programming? Do I have any questions? Okay. So if if we don't have any other lab sessions, so okay, I am going to use 1 second. Multi-class, how to calculate F1 score? Okay. So when you have multi-class, you have to because precision recall will be for. So you have when you have multiple things, you have to do something called macro average precision or micro average precision. Similarly, you have to estimate uh, macro average recall or average recall. Then using those average, you have to calculate harmonic mean between them. What is this? So this part Gyanendra was supposed to do because of this technical issue. Let me try to do that. Okay. So, as I said in the beginning, can you see my screen? As I said in the beginning, nowadays building a classifier is very easy steps, okay, easy process. So that's why everyone is doing learning now. So we have understood some high level understand, have discussed high level understanding of those different classifiers. Now I'm going to explain how to build those classifier using scikit-learn library. Okay. So for this, uh, we have uploaded three different say data sets. So one of the data set is something called, this is assets used for finding the building the classifier for sentiment analysis. Okay, so let me just give a brief background of the data sets. So these are the collection of tweets and the class levels. If you see every line is a tweets. Okay, and last character line says something like 1 or 0. So this 1 says that this tweet is having positive class, and so this say these top level tweets are having 1 1 1. That means all these tweets are having positive, okay, positive class. Find 0 0 0. So it says that this lower part tweets are 0 0. Okay, so that this is nothing but I have the tweets and the corresponding class level. So this is the annotated data sets. Okay, so now I want to build a classifier using these data sets. So this is basically how you are going to get when you try to build a classifier in the text domain. So the text might be, if you are doing something like document classifications, you will have documents, collection of documents, and each document will be having some class levels. Likewise, if you're doing sentence level classification, you'll have collection of sentences. Each sentence will have one class levels. Okay, so now so in this examples I have collection of tweets, and each tweet is having a class sentiment level, either 1 or 0. 1 means positive, 0 means negative. Okay, so now I want to build a class for using these data sets. So what is the difference between this data set and the example data set that we have taken in my previous discussion? So in our discussion, I'm assuming that my samples are already in the vector space model. I have already decided the features, and the hybrid vehicle is represented in this vector. In this example, you are just having the text. I do not have, so they are not in the vector space model. So given from your first task is to convert every tweet into vector space model. That means every tweet will be represented by a vector. Okay. Then how do you get the vectors? So vector means you have to first decide what are the features that you are going to consider. So in the text mining, or say in the text domain, okay, how do you define the features? So in the text domain, features might be defined using something called unigram or bigram, trigram, and so on. What do we mean by unigram? Unigram means in every words in the collection. Every words means in these tweets, you first extract all individual words, unique words. Okay, all these unique words are unigram. So you consider unique words as a unigram, unique words as a features, and build the feature space model. If you say bigram, what do you mean by bigram? You are two consecutive words. Say if I say he who exhausts or something, he and who will be one features, who and the actual should be one features, and likewise two consecutive words together will form one features, one bigram. If you say trigram, you will be considering three consecutive words. This is one feature, this is another features, and so on, trigram. So whether you are going to work in unigram or bigram or trigram, you have to decide. So if I say I'm going to work with unigram, then I have to first find what are the list of unigram from this data text collections, and using the as features, individual tweets will be represented by a vector. Okay, so that is what I'm trying to show. So if you are with me, okay, you can follow me by small quotes. Okay, are you facing any problem writing this program? So first part is something like I am just trying to read my text collection, the tweet collection. This is the Python program. So I'm opening the file called sentiment.txt, but that is nothing but my document collections. This is the sentiment.txt, which is nothing but this. Then I am reading the corpus. So the reading the corpus. So then I just to see whether I am reading correctly or not. This and when I run this, you can see that the first what. So when I give here 0, this is the first tweet. One, this is the second tweet. So like this is second tweet. You can easily see this is the second tweet. Means I am able to load. I am able to read this file. So now this sentences is having all the sentences read from my read from this corpus. Okay. Now I need to extract features. Okay, for as I just features might be unigram, bigram, trigram, and so on. Now in this example, I'm just considering the unigram. Can you Python notebook? Yeah, we are going to share it. Gyanendra, can you now upload this Python program, Jupyter program into this one, GitHub?
Yeah,
So
upload now, sir.
yeah, Gyanendra will be uploading, but in between, you can please, understand what is the process. Okay. So extract the say feature that basically means I want to open these text files and extract all the say unigrams as a feature. That's it. That is what I'm going to do. Okay. But in text mining, something called stop words. Stop words means some words which are very commonly occur in many documents, in both positive document and negative documents together. Okay, so those are kind of stop words. So sometimes we also remove stop words. It's not mandatory, but you can remove stop words. So removing stop words sometimes will improve your classification performance a lot. So stop words are very commonly occurring words like a, articles a, and the, above, and so on. So these are just some examples we have added. Using so this and as you see in the tweets might be having some URL, some special correct symbols, and so on. So we are writing some pre-processing methods here, just cleaning data cleaning part. In this data cleaning, what we are doing is we are removing the stop words, removing the URLs embedded in the tweets. Likewise, if you want to remove hashtags, mention, or emoticons, and so on, you can remove. You have to clean remove all those first before starting. So this is the cleaning, data cleaning phase. Okay, part will clean my say what it does is it will read tweets and clean the tweets by removing stop words. And so this, so when I have this, it is clean. So in this program, I'm calling the function called clean text cleaner. It will clean every tweet, one by one, and clean those special characters, and create try to identify the unigrams and find the vocabularies. Okay, so now this loop will, what it will do is it will read every tweets and identify the unigram. So now after this, if you see here, I am having some 12,000 unique words. I have in my data set is about 1,000, and you are having 12,000 number of features. So this is the challenge in text mining. The number of features is going to be really big. Even with 1,000 number of tweets I have considered for this demo small data sets, I'm having something like 12,000 features. That too only for unigram. If you are considering bigram, trigram, it is going to be in terms of maybe around 50,000 also. Okay, so that is what the number of features that you are going to deal with when you are using text. So I can also see what are these features. I think if I just say print unigrams, these are the features that I am considering. Okay, these are the unique words. So there are 12,000. There are 12,213 unique words. Okay. So now I have the unique words. These unique words are the features. Now I have to convert every tweets in the vector space model that we just discussed. So likewise, I just to represent, give the conceptual understanding of this. In this, I have F1, F2, F3, and up to Fk. These are the features. That is nothing. These are the unique words, and every tweet will be represented by a vector. This is the vector, and the where W11 is the weight assigned for this feature F1, the weight assigned for F2, and so on. Okay. So in text mining, how do you calculate these weights? There are various methods. One of the simple method is something called Boolean. Boolean means you just say yes or no, whether this unique word is present in the first tweet or not. If it is present, this is 1. If it is absent, this is 0. Okay, this if you, so if you are doing present and absence, then it is the Boolean vector space model. Instead of just also say how many times this unique word is present in these tweets. That is called, you can also say term frequency. Likewise, you can have something like TF, IDF, you can have BM25 and so on. You can have different weighting methods. Okay, so this is up to you what weighting methods you are going to use. Okay, this is the index weight. So in this example, we have considered Boolean space model means we have just considered presence or absence. Okay, if a unigram is present in a tweet, then I would say 1, otherwise this is 0. Okay. So likewise, putting every tweet into the vector, then I am okay. Yeah. This is just the sample examples of how I am creating the vector space model for the first tweets. Okay, so I am using for the first tweets, tweet number 0. For tweet number 0, 1, 1, and so on. The rest are 0. That basically means the first unique word is present, second is present, absent and so on. Okay. So this is what the what I get. Okay. So now this is the document ID. This is the vector. At last, you have class level. It says the first tweet is positive, and this is the vector. Okay. So likewise, I have created the vector. Every document is represented in the vector space model. Okay. So at this stage, what I have is nothing but this table. Now I have this table. So this table is like, say, you have the and this of this vector and a level, right? So this table is what I have now. Okay. Okay, you are asking to zoom a little bigger. So now what I have now is the this data set in vector space model, same as this table. Now once I have this, now I can apply classifier. So now when you do any experiment, data sets, right? You have to divide your data sets into training and testing. Okay. So this is what I'm trying to show, because this is what exactly you're going to do when you actually build a classifier and check the performance. Because the data is only this sentiment dot text. So I have to use some part of this as the training, some part of this as the testing. Okay. So that is what I'm going to do. Okay. So now, so if you see the original is in all five positives are together, all negatives are together. Just random mixing, we are just doing the random sampling. So when I do the random sampling, what happen is everything will be mixed. Okay. So after that, I have so is we have done the random shuffle of the vectors. Vector is nothing but these vectors. Then I'm separating x is the x here. This x is the feature part. This y is the label part. Okay. I'm just separating this part.